Well, thank you so much for being here. This is our
Mhm.
first paper walkthrough ever for UniverseTBD. And today I decided to talk about, with you, to talk about can large language models generate novel research ideas?
Mhm.
So, just to kind of give you a bit of a background, this paper was done by a wonderful PhD researcher at Stanford. I met with him, Cheng-Lei Si, and they've done a very large scale study that took over 1 year with 100 NLP researchers. And the core question of the study was, can large language models generate novel ideas as compared to human-generated ideas?
Mhm.
So what prompted the paper was that the authors really sort of wanted to understand the potential of these agents, AI, to sort of accelerate scientific discovery. But they discussed very early on in the abstract that this is a hard task, not necessarily because of the generation aspect, but also because of the evaluation aspect. So it's extremely hard to generate ideation, to evaluate ideation. So yeah, so in order to tackle this difficulty, they were like, there's no better way than to do it than having human evaluators generate
Mhm.
these ideas and then comparing AI and human idea. So yeah, so this is the first head-to-head comparison between expert NLP researchers and LLM ideation agent over a very large scale, over a very long time.
Mhm.
Yeah, so I guess the introduction is, yeah, any thoughts? Like, what do you think that, is this like a good idea to start here to do like a very large scale, long time evaluation paper,
Oh.
right?
From a practical point, I think no, because it does waste a lot of human manpower in checking whether those ideas are feasible.
Mm-hmm.
Um, but until people actually do this and put it like if it's this is put into practice and people actually start working on this and it leads to results, then I'll change my mind because I can't argue with results, right?
Yeah, yeah, yeah. Cool.
Mhm.
Yeah. So I think in the paper the authors also discussed that this is extremely expensive
Mhm.
manualism. So I guess if we go through introduction, what they do here, yeah, exactly what you're saying. Qualified expert researchers are difficult to recruit at scale, and evaluation criteria can be highly subjective, and it's very hard for people to judge the quality of an idea and actually go quite deep into this. And they discuss that, it's hard to judge an idea without seeing the experiments. So
Mhm.
just at the ideation stage rather than like the experimentation stage, just that first part is very hard to judge without the follow-up.
Mhm.
Um, but they also make this point in the introduction that for high stakes research tasks like research ideation, there is no substitute for large scale expert evaluation. And they go deeper into this, and I'll show you some results
Mhm.
about LLM as a judge, and that LLM kind of fails as a judge in this
Mhm.
particular task. Okay, so right, so I guess the problem setup is the following. Um, Yeah, so it's pretty much a comparison of human and LLM generated ideas, very straightforward. But what they want to do is that they want to focus on three different components. So when it comes to evaluating an idea, you have the idea itself, you have the write-up, and of course you have the evaluation. And here, for example, where they talk about the write-up that communicates the idea, they talk about the style.
Mhm.
So humans have a very different style than LLM generate the
Mhm.
idea. So you can think about the humans have more, they may be more informal. In some way, I actually think that, yeah, they even go here and say that humans may tend to write in a more engaging and informal tone. So in order to sort of standardize between the styles, they actually um, introduce a template. First of all, they introduce a template to specify for the LLM agent. They say, okay, this is the template that you have to follow. I think it's in Appendix B. the structure and detailness of the idea. So if we look at, like, I think I went through there. Let me show you. Right, where is this? So, yeah, where is the B?
I
Okay,
think it was Appendix D. Oh no, there we go.
this
Okay.
is, yeah, this is the one. So, yeah, so first of all, what they do, they're like, okay, AI and human, you guys have to like pretty much follow the same structure, title, problem statement, motivation, post method, step-by-step experiment plan, test case examples, and fallback plan. And they discuss in the paper how long, for example, is a human-generated idea. So it's around 900 words. So this is like a very like in-depth template. All right, so once they do that, for at least for the evaluation part, they also standardize the style using another large language model. Let me see where they said that. Yeah, so we developed a style normalization module that uses an LLM to convert all ideas into the same writing and formatting style without changing the original content. Um, so that means that once they do that, they do a bit of a small study that shows that this leads to a 50% accuracy, so random, right? If you ask a human to distinguish between AI and LLM
Mm-hmm.
generated ideas, at least to the basis of the style, like they
Mm-hmm.
can't do it. Any thoughts so far on their approach to providing the structure, sort of standardizing the style? Um,
The first question is, they say lead to a 50% accuracy, but did they show any metrics on how they evaluated it?
this part, the
Mhm.
this part of like distinguishing between the style of human,
Yeah.
I don't know. Yeah, I think they proposed the full prompt. We can have a look here. So yeah, so this is the prompt they give to
Hmm.
the large language model. But I don't know if there's more details about this particular part. Yeah,
Okay.
yeah, that's a great question.
Hmm.
We have to go through the paper. I've gone through it quite fast.
Okay.
But I'm sure they did, I'm sure. All
Hmm.
right. And the final part, like before we go to the ideas, is what yeah, so I guess right now we're discussing more the evaluation part, and then we'll talk more about the generation part. So yeah, so they kind of looked at what are the reviewing criteria for the top CS conferences, AI conferences, and they come up with novelty, excitement, feasibility, and effectiveness apart from the overall score. So they have sort of 5 different criteria. And like, the gist of the paper is that they ask a bunch of humans to come up with two idea, and then the LLMs as well, and then they just evaluate across these 5 different buckets. And they
Hmm.
use a numerical score on a 1 to 10 scale, along with a free text rationale.
Hmm.
Yeah, so it's quite straightforward, their evaluation strategy, right?
Okay.
Yeah, it consists of having a very well-defined prompt,
Hmm.
standardizing the style, and including these 5 metrics.
Hmm. Okay.
Okay, so then in the paper, they continue the paper with, after they discuss evaluation, to sort of talk a bit about how the LLM generates ideas. So for human, it's kind of straightforward. You just ask them to follow the template and to come up with the idea. They pay the humans actually. They pay $300 for idea, and I don't know how much money they pay for the evaluator. And I'll show
Hmm.
you some results to sort of how they picked the humans as well. I mean, I'm excited to hear your thoughts there.
Hmm.
Right. So for the generation, for the LLM generation, they say that they want to stick to a minimalist design principle. I think that you might like that because I like complex systems, but I think I really, really like the fact that they wanted to sort of just see to
Hmm.
first degree how it works. Um, and has 3 essential components. So paper retrieval, generation, and idea ranking. So at the generation stage, or the idea generation stage, they first retrieve some relevant papers. They sort of integrate these papers into some generation prompt. And then finally, they have a ranking by another large language model of these ideas. So yeah, so the first part, the paper retrieval, I guess they used Claude, which apparently is the sort of the best one. How did they get to that? I mean, I didn't see why they chose Claude 3.5 Sonnet for this task, but I assume this is a very well behaved large language model. Um,
Can I interject a little?
yeah, of course you can at all
Okay.
times. Yes, this is the
Okay.
first time we do it, but sure, yeah, like
All right.
regular. Yeah.
I think so. The date on Claude, it's the 20th of June last year. So I think this was before GPT-4o came out. That's why, and the Claude was, I think, the best performing model then. I think they
Yeah,
still actually do have 3.5 at the moment, but it's a very good version.
yeah.
So I think that it makes sense.
Yeah, you're right. You're right.
Hmm.
This is indeed this paper was published, I think, a year ago. I didn't
Hmm.
even remember that. Yeah, that's great.
Hmm.
Yeah, that makes sense to use state of the art.
Hmm.
Right. So what they did then, it's an agent, and they asked the agent to get some papers that have certain keywords. So, for example, they have this one here, novel prompting methods that can improve actuality and reduce hallucination of large language models. So, yeah, so TLDR, they only want to focus on one particular topic in the field of NLP, and they
Hmm.
focus on prompting techniques for NLP
Hmm.
research. So, they ask the humans and the LLM to generate ideas only in this space,
Hmm.
to remove bias and stuff. Yeah, so so they asked it to find the keywords, find papers that have these keywords, get the ID, and then get also the references of that paper. And then what they do is that they keep the top 20 papers from each executed function call, and then they stop when you get 120 papers.
Hmm.
All right, and then they use the large language model to score and re-rank based on three criteria: relevancy, empirical paper, and it's interesting. Yeah, so what do we think about this sort of retrieval ranking part? Yeah.
Um, so there are much better methods now, but
Mhm.
they only got popular towards the end of 2024. So I'm not going to say what they did is like wrong. It's just that there are better retrieval methods available today.
I mean, I have not been keeping up a lot with retrieval lately. I've just been thinking more about reasoning. What are some of these methods? Then,
So, well, it says that. So let me focus on this specific sentence here. The paper retrieval action space includes keyword query, paper query, and get references. Some investigation has found out, I don't recall the exact authors, is that querying for keywords rather than looking at just embeddings of those keywords is a little more efficient and it gets you more relevant responses.
Mhm.
And asking for better types of, or so the prompt I noticed did not include the things like the React framework, which came out towards like more agentic, when like agents really blew up. Asking the LLM to reason why it looked at these specific words, asking if it made any biases in like only choosing the list of or like only looking at the list of documents it retrieved most recently, things like that. You have to handle that when going into kind of like actually working with LLMs in production. And people have come up with all sorts of tricks to make it work better. And I was gonna say this at the end of the talk, but some people have. So the Allen Institute for AI
Mhm.
has already made an LLM that does scientific paper retrieval.
Mhm.
It doesn't generate prompts, but they have a very well work like a system that works very well at querying open papers and
Mhm.
um, getting you like a lot of scientific references really quickly.
Yeah.
So if I was to design this in the modern day, like today, I would make it significantly different rather than just using a single LLM.
Absolutely. Yeah, this is fascinating that this was like the pace of it, like the pace of changes so fast. I think like
Yeah.
1 year ago, and now it's like we're a year ago we were not in the modern day. This is interesting to me. Yeah, I just like a tangent there.
Yeah, I mean, like I said, when they did it, it wasn't wrong. And of course, they can't be expected to know all the tricks people came up with later on.
Hmm.
Um, and I haven't seen the results of this paper yet, so maybe the results are good.
Yeah,
Um,
yeah. I'm just
like if it works, it works. My personal opinion, after having worked in the space a little, is that LLMs are the LLMs that are available to the public are a little weaker than they used to be. And to compensate for that, there are all sorts of tricks you can use to make their responses stay uh, like has still have like maintain that high quality that they used to have on release. But yeah, the so if anybody watches this talk later, then Allen Institute's open. So they changed its name. It was called Open Scholar until last week, I think, and
yeah.
now it's called OpenSci LLM.
OpenSci LLM. Yeah, I think maybe we can just sort of. I would like to try this out
You
actually.
can look at it right now. I think it's free to use.
Yeah, yeah, yeah. I'll definitely. Yeah,
Yeah.
I'm scared I'll break my setup. I'm terrible with tech, so I'll probably just keep the paper. But after our call, I probably will go and have a look. I've been trying deep research, to be honest with you, but that's sort of like the next after retrieval,
It's
right? Like you have
it's
sort of the
two hundred
integration.
dollars, right?
Yeah, 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 it's expensive. I don't eat 2 days a week, so that's it's fine. You lose weight. Yeah, we shouldn't say this on public call, but you get more healthy as well. Like, you're eating healthier because you're like,
Yeah.
I have limited resources because now I pay for deep research, so I'll invest in
Mhm.
good food instead and cook food now. Yeah, so you cook twice. Okay, I'll stop now. So it's
Mhm.
cooking with deep research and also cooking yourself. Right. So going back to the paper, I think, yeah. So right. So just generally, they had 6 function calls. They stopped when they got 120 papers. And then once they got these 120 papers, what they did is that I think my understanding is that they put them into the idea generation prompt in some way. So they take 6 research topic. They take how many research topics they take? So I'll try to find. Maybe I didn't show you this part. Um, yeah, no, they didn't mention it yet. Right. So yeah, I guess they have some research topics that they pick from the from the con conference. Um, I guess where are they? They're not here. Yes, no, where are they? Um, yeah, so here. So they pick 6 research, they pick, I think, how many? 7 specific research topics from the call from papers page of NLP conferences. So they're focusing on bias, coding, safety, multilinguality, factuality, math, and uncertainty.
Mhm.
So like generate ideas across these 7 topics. Yeah, did I? Yeah, that's fine. I should have mentioned that earlier. Yep. Where is it? Yeah, here. And they say, okay, generate 4,000 seed ideas on each research topic. They also give 6 examples by manual. They actually curate 6 examples.
Mhm.
So yeah, so here for retrieval augmentation, they have 10 papers from the top ranked retrieved papers, and they put the titles and abstracts to the prompt. They also put the prompts of all previous generated ideas, in the 120, I think, to the prompt to ask the LLM to avoid repetitions. And they also give the 6 one that they have humanly curated.
Mhm.
And then, yeah, and then they come with ideas, but they also do this sort of what I really like, this sort of remove the duplicated ideas.
Mhm.
And this is a fun part. They say there leaves about 5% non-duplicated ideas of all generated seed ideas. And there's a
Mhm.
really fun plot they have. We'll show the results as well. We have a bit of time. But this is a really interesting plot in figure 4. So here is on the y-axis, you have the non-duplicate percentage. So I guess you get the unique ones. And then here is the total number of ideas generated. And you can see that there's quite a saturation happening.
Mm-hmm.
So this kind of speaks to the problem, and they talk about this problem here that LLMs lack diversity in idea generation.
Mm-hmm.
What's your experience like? I think this is something I've seen firsthand as well with my
Mm-hmm.
experiments. Like it seems like there's a upper ceiling to how much I can squeeze out of these LLMs when it comes to ideas. Now with the latest ones, like the O1, O3 models are a bit more, yeah, takes a bit more.
Um,
Yeah.
my experience is that at some point the LLM at some point when you ask it to dive deep into a topic, um, it gets confused. I can give you a straightforward example. If you ask the LLM to, if you go to ChatGPT o1 and ask it to explain how, for example, a convolutional neural network works,
Yeah.
first it will answer with the jargon that's used in CS papers, which
Mhm.
is fine. And if you ask it to really explain the jargon and explain the mathematics of it, it very easily gets confused. This has been like a big problem if I try to use an LLM to understand the paper because you can kind of tell at some point that it's kind of glossing over the actual insight or how the actual mathematical computation is done. I suspect that it's because its reference pool is scientific papers which are written ideally by experts for experts, so everybody knows what they're talking about.
Mhm, mhm,
Um, but I mean, it's difficult. Like aside from the very basic like operations, like of course, if you tell it to explain how convolution as the operation defined in machine learning works, it will do it. But then it struggles to explain how the numbers actually get computed and flow through the system. For lack of a better phrase.
mhm,
And it tends to it's very hard to like get it to reveal the actual insight behind something.
mhm. And have you found that, have you found that capability with humans, like looking at lectures online or like I almost have like a sense for, I'm terrible at explaining things, but I think the when I find a great teacher, I'm like, oh yeah, they really deeply understand this process. Like, yeah.
I mean, I'm gonna do a little bit of advertising, I guess.
Yes. Yes.
I
Good.
have so back in December or late November, I think it was early December of last year, I was trying to really understand the transformer architecture because the paper that popularized it, Attention is All You Need, the actual explanation of the attention mechanism is really weird. I suspect that it makes perfect sense if you're in NLP, but to an outsider, it's really weird. And I struggled quite a bit to understand why attention worked and kind of how it worked.
Mhm,
Now,
mhm.
the end result of that is that I ended up implementing a transformer in NumPy. Uh,
Yeah.
no PyTorch abstractions or anything. So that involved doing like backprop and everything by hand. And of course, now I know why it works, how it works, why they call it attention, kind of like that. But all attempts at getting an LLM to explain this to me straight up failed because it kept repeating the words key, query, value, matrices, and there was no insight behind its responses.
Yeah.
So I feel like at least once you have to have a teacher kind of hold your hand or walk you through the actual computation of something.
Yeah. Struggle.
And that's
So,
something LLMs can't do.
yeah, I think there is a very interesting insight here because I also feel quite in a similar way. So it almost I have to code something from the ground up to be
Mm-hmm.
able to really get it.
Mm-hmm.
Um, I don't know that maybe this is a very human thing. I don't know why we're it's very
Yeah, I mean, if if we have time, we can probably test it experimentally. I guarantee you that at this point, ChatGPT will still show the same thing. It really won't explain how and why a thing is done.
Maybe this, I mean, everything I hear, I'm like, is, calling for a benchmark, benchmark, benchmark. Like, these are like large language models in the world for the use of like deep dive in expertise, all these things. So I'm happy you have an internal benchmark for these methods. I do as well. So just want to hear
I
this.
mean, I think it's like if an LLM can explain to me in a way that makes me able to, or like allows me to understand it, then yes. But the problem is that what are like the use cases you use LLMs for? Often, at least in science, I think people use LLMs to help them understand new papers.
Yeah, yeah.
Um, and often what happens is that the person who's feeding the paper to the LLM doesn't know what the paper really does. Maybe they've read the abstracts and the methods, but like actually going through the paper line by line and doing all the computations by hand. Um, that's something even an LLM can't explain. It just doesn't work. It just doesn't know how to explain it, I feel.
Yeah, I think like if we have time, we can chat. I have some thoughts here as well. About, when you read a paper, if you ask a large language model to extract the key information of that paper,
Mhm.
you get, like the key parts of the paper, but it's almost as if I have to reread the paper to
Yeah.
integrate back what the LLM said. Um, I think context is for a human context is also deeply important.
Hmm.
Having like a contextual base
Hmm.
somehow. Right. So yeah. So anyway, going back to where we were, because this course is super fun. I love it. But we haven't gotten to the results yet. So
Yeah.
oh God. And yeah, and like once they do the generation, they also have this third part that's very important for them, which is an idea of ranking. Um, yeah. So they say that, like if you ask a large language model to predict the final score, it's not very good. But if you ask the large language model to say which paper is better from a pairwise group, then it's a like the LLM is a better judge in this case. And they took like ICLR submissions, I think 1,200 of them, and they asked Claude Sonnet to they took like the top the ones that were accepted, the ones that were rejected, and they asked the sonnet to see which is which, and he said that he got a accuracy of approximately
Hmm.
71%. And then here, like, I think they had access to GPT-4o that they
Yeah.
just 61.
I guess I was just misremembering, but
Yeah,
GPT-4o in the modern day is not as good as it used to be.
yeah, I mean yeah, I hear that. Oh, it's weird. I wonder.
Yeah.
It's a very deep question.
Hmm.
Um, so they pretty much just said that for their idea ranking, they enabled a tournament systems.
Hmm.
And yeah, so finally they say that once you have the generated idea, you have three conditions. You have the AI generated ideas, the human ideas, and then you have the AI ideas that were re-ranked by the first author of this paper. So these are the three conditions that they are sort of using. And yeah, because we're slightly running out of time, I'll
Hmm.
show you how they picked the reviewers and the writers.
Hmm.
So they had 49 writers and 79 reviewers. Most of them are PhD researchers, and for the reviewers, you have postdoctoral researchers, and you see 73%, some
Hmm.
masters. And here for the reviewer, you also have the postdoc.
Hmm.
And then this is their research profile metrics of the participants. So pretty much, yeah, you're looking at a median or mean of 12 papers for the generators and maybe two papers for 15 papers for the reviewers. So, it's a strong pool. Yeah, it's a strong pool of NLP researchers. Yeah, so I guess they did it at large scale. And then the results are actually in figure one. So we have to go back here. Yeah, so is there figure one and two? So are there any questions on how they devised the system? Though they use the retrieval, they use the generator, they rank them, and then they had this like very like diverse yet
Hmm.
expert pool of researchers that created and evaluated. Yeah.
I don't really have a problem. I was interested to see that they used a Swiss system,
Mm-hmm.
but hey, if it works, then I'm not questioning it. Like,
Why?
it's not something I would have thought of, like having prompts compete against each other.
Yeah. It's tournaments are, yeah,
Hmm.
they are actually, in my opinion, they're a good way to, yeah, I guess
Hmm.
rank things. All right, so in the figure, yeah, so just to kind of review what the paper has been doing, 7 NLP topics, we have the human experts, we have the human agent, um, 49 people come up with human ideas, and then the AI agents come as well with AI ideas, and you also get the same numbers, so you can compare them, and then you can also re-rank them by the first author, so these top ideas. And I can refer you back to the paper if you want to read more depth of
Hmm.
how they did this. And then for when you use the experts, sorry, when you use the experts here, 79 experts, you get that the novelty score is 4484 for the humans and 564 for AI and 581 for AI plus human re-rank. And I guess here in figure 2, you can kind of see the whole 5 buckets: novelty, excitement, feasibility, effectiveness, and overall. On the x-axis, you have the condition, human AI re-rank, and the y-axis, you have the score. And they're saying there is a statistical difference here. I think they did some detailed t-test, two-tailed wedge t-test here with
Hmm.
some Bonferroni correction. It's been a long time since I've done that, so I don't remember exactly what this does. But regardless, they were testing the null hypothesis, and they're saying, okay, yeah, human is very different than AI, and AI plus re-rank, and on average, like I guess the main result of their paper is that yes, indeed, as evaluated by human experts, large language model ideas that were ranked by a human or not re-ranked at all by a human were more novel
Hmm.
than human ideas. I
Hmm.
guess that sort of how this is the main result of the paper. This is what we've been
Hmm.
building up to. Not the same for feasibility. So feasibility, you see, they're not quite as feasible. It seems there's a slight correlation. They actually compute the correlation between all of these various buckets, and they say that novelty does come with some link between novelty and excitement, but not with feasibility. So it's almost as if we really extrapolate a little bit here, say, okay, the LLM generates more novel ideas, but they're not quite as feasible. That to me makes intuitive sense, I think. Yeah. I wonder what you think about this result. Like, is this something that you expected or something completely unexpected?
As someone who's not in NLP,
Yeah.
I honestly can't have an opinion on this because
Yeah.
if it was my field, if it was like space physics, things in the ionosphere, then it would be interesting to see if I was one of the people doing this stuff, or what was one of the people evaluating this, whether I'd get the same distribution.
Mm-hmm.
Um, and in general, I'm a little skeptical of like defining not arbitrary, I guess, but kind of weird metrics like novelty, feasibility, effectiveness. So I don't really have an opinion on this.
Yeah, it's extremely hard to, I think evaluation is a really tricky thing.
Hmm.
I mean, where they went with paper after all, once they had this really sort of intriguing result, I expected this in some way because I feel like it's almost that the large language model hasn't been, doesn't have an sort of inherent sense of what will work later down the line without the experimentation. So I would say that the feasibility score, I expected that to be lower than the human one. Human has a lot of intuition because they've run many experiments.
Mm-hmm.
But yeah, they actually go back to the paper and they say, okay, what can possibly be wrong? What can possibly explain or you know contribute to these results? And people are, in the paper say that human experts may not be giving their best ideas, but that's not really the case because yeah, they said that this was sort of top 43% of all their past ideas. Then they were saying that reviewers tend to focus more on novelty and excitement. Yeah, and I think they actually said that this is true. Maybe I'm wrong, but I think by reading this part, I remember they were saying yes, they do tend to care more about this part. And finally, they talked about these reviewing ideas inherently subjective, and they went into a kind of a big analysis here to kind of like get the interannotator score. And that's, that's also, I think, anecdotally, I know that that's very true.
Mm-hmm.
It's very high, it's very subjective reviewing ideas.
Mm-hmm.
And then they talked a bit about what happens on the side of large language models, like they may lack diversity, cannot evaluate ideas reliably. Um, so yeah, so if you pretty much put two humans to agree and then you quantify the inter-agreement score, inter-annotator score, and then you have a large language model to sort of agree with humans, you find that the scores are lower between. So yeah, so human plus AI is lower than human in terms of agreement.
Mm-hmm.
And finally, yeah, that's it. I think and finally they're saying, okay, how can we do this better for the future? They say that they will probably ask human experts to follow up with some of these ideas that were generated by the AI and actually do the full process of the paper and then evaluate at the end. And that will be a
Mm-hmm.
more natural evaluation, because you can submit the paper to a conference and then you get a full review from the reviewers there. So yeah, so I think like the final part of the paper is like we need to scale this up. We need to actually let the ideas be run through in order to properly evaluate them. But it's extremely
Mm-hmm.
expensive, time-wise, computationally wise. But yeah, it's like exactly as you said when we started. It's like kind of
Mm-hmm.
yeah, you need it. You need it the first time. You need it. You need to see what happens the first time.
Mm-hmm.
Yeah. So yeah, so this is sort of a very brief walkthrough to the very big paper, 20 pages paper.
Mm-hmm.
Yeah, I liked it because I really care about like large language model and research ideation.
Mm-hmm.
Just think what's the best way to sort of elicit this behavior in an LLM where it gives you, I don't know, it gives you like a great spark of an idea that you can then work on. Um,
I mean, presumably, if you get an agent, I'm going to call them agents now too, run a bunch of experiments and then ask the LLM to give you a prompt after doing some work on its own, then maybe it'll be better.
yeah. There is some work done in this direction. I don't know if you've come across a virtual lab.
I've
Actually,
heard of it. I didn't you post it
yeah, I
somewhere?
post things. I know. I'm sorry for spamming.
No,
Uh,
no, it's fine.
yeah,
I mean, I've been meaning to ask you about that, but after the talk.
after that. Yeah, well, I guess, I hope that the peeps watching this, if someone watches this, are gonna
Mhm.
enjoy our sort of deep dive in this paper. Maybe we
Mhm.
can have a similar sort of style next time, but I can be
Mhm.
more on your side and you can be more on my side. We can see. We
Mhm.
can we can choose papers that we like. I really like to do this because um, yeah, I find it very, I think Neil did this. I think Neil Nanda did this very nice paper walkthrough
Mhm.
and I learned from him. So thank you. Thank you so much for putting up
All
with
right.
my waffling as well. Yeah,
No, no, it's fine.
it's all right. How do I do this? Stop recording.